Hello everyone, myself Mr. Bulake Bawashok रहे शिक्षण संस्थात आबासाहेब मराठे Arts and New Commerce Science College Rajapur. Today's lecture we are going to discuss the topic phenol. In this topic, we have see we have synthesized research phenol from benzene M disulfonic acid. In first step, the benzene is converted to M disulfonic acid by hot fuming sulfuric acid. This benzene we can treat with the H2SO4 at 90 degrees centigrade. Then what happens? The sulfonation can take place at the meta position with respect to each other. Means the sulfonation at meta with this, and this is meta with this. So sulfonation can take place at the meta position. The disulfonic acid, which is fused with excess NaOH at 270 degrees centigrade, then it produces disodium salt. Here, these benzene disulfonic acids are treated with this sodium hydroxide at 270 degrees centigrade. Then what happens? It produces a disodium salt. Here, it produces a disodium salts and sodium sulfate plus the water molecules. Then this sodium disulfonate we can treat with simply by using a dilute H2SO4. Then what happens? This O minus pick up proton here. Also this O minus pick up proton is here, and to form O minus convert to OH is here. Also OH is here, and the product name is a resorcinol, and byproduct is sodium sulfate. So by using this method, we are prepared the resorcinol from benzene using these three steps. What is the first step? First step is convert to benzene sulfonate, M disulfonic acid. This meta disulfonic acid which convert to disodium salt of benzene. Then this treat with dilute H2SO4 to convert the resorcinol. Next point, now we have see it here, the sulfonation of naphthalene with concentrated sulfuric acid at 80 degrees centigrade. It gives one product is 1 naphthalene and second product is 2 naphthalene. But we have see is here, the 1 naphthalene take place at 80 degrees centigrade and 2 naphthalene is take place at the 160 degrees centigrade. We observe that the two different temperatures, it gives two different products. But why it is observed? Because the sulfonation of naphthalene with the H2SO4 at 80 degrees centigrade, it gives mainly alpha naphthalene, and whereas same reaction we are carry out at 160 degree centigrade, it gives the beta naphthalene. Naphthalene sulfonic acid on neutralization with NaOH to gives the corresponding sodium salt like sodium naphthalene sulfonate, and those naphthalene at 80 degrees centigrade and 160 degrees centigrade. The 80 degrees centigrade it is a kinetic product, and 160 degrees centigrade it is a thermodynamic product which will be formed. Now next new reactions we have see here. If we add the sodium 1 naphthalene sulfonate at 300 degrees centigrade in sodium hydroxide, what is the product will be gives? The alpha naphthol it gives as a one alpha naphthol, another name is a 1 naphthol. But how will your reaction can be proceeds? In first step, what happens? This the sodium 1 naphthalene sulfonate, are fused with this sodium hydroxide to get the sodium 1 naphthoxide. And this sodium 1 naphthoxide, which on acidified with the dilute H2SO4, then what happens? This O minus will take the proton from this acid and to convert is OH. The name is a 1 naphthol, or another name is a alpha naphthol. Similarly, the other reactions we can done like sodium 2 naphthalene sulfonate are fused with sodium hydroxide at 300 degrees centigrade. It gives a sodium 2 naphthoxide. This sodium 2 naphthoxide, which one acidify with the dilute H2SO4, then what happens? This O minus pick up the proton from this acid and is converted to OH. The product name is a naphthol, or another name is a beta naphthol. This is a alpha position and this is a beta position. So name is a beta naphthol and it is a alpha naphthol. So two different products will be formed having a at higher degree temperatures by the sodium 1 naphthalene sulfonate and sodium 2 naphthalene sulfonate. The next method we are used to prepare the phenol from isopropyl benzene. These methods or these reactions are very important. Accordingly, the final year exam. So phenol can be prepared from isopropyl benzene. Another name is cumene. So this is another name is cumene. So how will you get these products? Our form are here. Like this method are used for the preparation of phenol itself. This is an industrial method for the preparation of phenol. The cumene, another name is isopropyl benzene. So this is a cumene. On air oxidation in presence of a catalyst like cobalt naphthalene, it gives cumene hydroperoxide. It gives cumene hydroperoxide. But such reaction will be carried out at 150 degrees centigrade in presence of a catalyst. But such type of reactions can take place at free radical type of mechanism. And then after formation of cumene hydroperoxide, then treat with dilute H2SO4 on heating, get decomposed and to form the phenol, and byproduct is acetone. So by using this method we can prepare the phenol as the product using industrial applications. Similarly, we can take the another type of phenol, will get the products like these 2-butyl benzene are are on air oxidation in presence of catalyst to give hydroperoxides, and those hydroperoxides which on heating with dilute H2SO4 it gives phenol as a product, and byproduct is the 2-butanone as the byproduct. So by using this method to prepare phenol as the target molecules, as well as the byproduct is ketone. The next points we are going to discuss the acidic properties of the phenol. The first property we have see here, steam volatility. Steam volatility means that we have see in phenols like para-nitrophenol. Hydrogen bonding has the larger effect on these physical properties like boiling point, solubility, steam volatility. For example, this orthonitrophenol is steam volatile, whereas para-isomer which is not steam volatile. Why it is observed? We clearly observe that is here the hydrogen bondings, which type of hydrogen bonding are here, and in this molecule which type of hydrogen bonding is there. So two types of hydrogen bonding which will affect on the steam volatility. In first molecules we see is here at a para-nitrophenol. This para-nitrophenol which is present intermolecular hydrogen bonding. You know that intermolecular hydrogen bonding which says in a Marathi like जर दोन फ्रेंड्स असतील, right? This is the one of the friends, this is a second friends. एका फ्रेंडचा हा जर आपण हँड्स घेतला आणि दुसऱ्या फ्रेंडचा जर त्याचा हँड घेतला, त्या दोन लोकांनी आपले हात जोडले तर त्याला म्हणतो आपण इंटरमॉलिक्युलर हायड्रोजन बॉन्डिंग. कॅन यू अंडरस्टँड? समजलं? हा एक मित्र आहे आणि हा एक मित्र आहे. काय झालंय, या मित्राने त्याचा हात दुसऱ्या मित्राच्या हातात दिलाय, त्याला म्हणतो आपण इंटरमॉलिक्युलर हायड्रोजन बॉन्डिंग, राईट? आणि म्हणून the para-nitrophenol which is not volatile compound, but in ortho-nitrophenol it forms intramolecular hydrogen bonding, and hence it is no association of the molecule in isolated form, right? इथे जर आपण बघितलं ह्या ऑर्थोनायट्रोफिनॉल मध्ये इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग आहे. इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग मुळे हा मॉलिक्यूल स्टीम व्होलाटाईल आहे. त्याच्यामध्ये असोसिएशन मध्ये दुसरा मॉलिक्यूल आहे का? नाही. आणि म्हणून हा मॉलिक्यूल स्टीम व्होलाटाईल आहे, हा मॉलिक्यूल स्टीम व्होलाटाईल नाही. बट यू नो दॅट इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग, intramolecular hydrogen bonding means the bonding which is present within molecules. म्हणजेच एकाच मॉलिक्युल्स मध्ये जर बॉन्डिंग होत असेल तर त्याला म्हणतो आपण इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग. फॉर एक्झाम्पल, हा एक मॅन आहे आणि या मॅनचेच दोन हात आहेत, हा एक हात आणि हा दुसरा हात. म्हणजे आपले स्वतःचे हात जर एकमेकाला आपण जॉईंट केले तर त्याला म्हणतो आपण इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग. यू कॅन अंडरस्टँड इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग म्हणजेच आपण एकच माणूस आहे, हा आपण स्वतः आहोत, हा आपला एक हात आहे आणि हा दुसरा हात आहे. जर आपण आपलेच हा हात आणि हा हात जर आपण मिळवला तर त्याला म्हणतो आपण इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग. दिस इज अ इंट्रामोलिक्युलर हायड्रोजन बॉन्डिंग. थँक्यू.